Welcome everyone to Singularity University's Global Summit Live here in San Francisco, California with my friend Brent Oster, the CEO of ORBAI. Brent, thanks for being with us.
Yeah, thanks for inviting me. Really cool to be here.
ORBAI. What is ORBAI? What's it stand for?
So ORBAI is Artificial Intelligence and Robotics, and late at night when I was looking for a name for the company, I took the letters of my name and AI, Oster, Robotics, AI, and just smooshed them together in 3 or 4 different ways until I found one that worked, and then claimed that one as a website.
I love that. I love that so much. Well, Brent, how did this fascination with AI start for you, and what's kind of your background?
Yeah, so my background, I worked, my degree in bachelor's is aerospace engineering. My master's degree was in scientific computing, and then I worked for the last 10 years at NVIDIA, starting out with scientific computing, CAD, visualization, visual effects, and then for the last 5 years there in deep learning and AI. And I worked as a consultant to work with companies like Facebook, Apple, National Labs, and other companies to help design deep learning solutions with NVIDIA hardware and software that would work for them. And so it was a really good deep dive into and working with hundreds of other small and large companies over that 5 years too.
And so for people watching this back home, Singularity is full of exponential technologies, futuristic technologies that are all around the room, scattered. And when I came across your booth, I saw this visual representation of it was a nurse.
Yeah.
And it's designed after your wife, is that right?
Yeah, so my fiance is in Honduras, and she is a clinical psychologist who works in Honduras, and we'll show it later. But so she...
What camera are we on right now? This one right here? Yeah, this one. Okay.
And she goes to remote villages, and there she's the doctora, so
Right.
she's called the doctor. And so she's been using WebMD on a cell phone to be a doctor in rural Honduras. And so we built a speech interface that could work with WebMD and other medical interfaces and do queries and answer questions for people verbally. So it made her job easier there, and that evolved into a visual representation of a person on a phone or a hologram that could be doctora in a country like that.
So in a country like this where it's hard to get medical attention, especially like you said, someone with a high level of education in the background, to get that attention. So what you've done is you have this projector like we have over there, and it's basically just an AI simulation of a doctor. And I can go in, right? And I can ask them if I have a hurt arm or something like that, or I have a fever symptoms. I can go in and ask the doctora what's going on with me, and she'll get back to me in real time.
Yeah. So we designed a system that's more query based. So it asks you a bunch of questions.
Okay.
So right now it's really hard to do a full on certified doctor AI in North America.
Sure.
It'd be ludicrously expensive. So we built a headache screening app as an example. So it'll ask you simple questions like, where is your headache, the front or the back? Does it last for a long time or a short time? It's so by a series of questions, it's able to narrow down, oh, you probably have migraines,
Right.
And here's the recommended treatments. So something like that, or a interview nurse that can do the first, you walk into the doctor's office, they ask you your background, do you smoke, what's your weight, do you exercise, what symptoms do you have today, what brings you in, and it can get that first interview out of the way and maybe even do your vitals. That would be an incredible help to hospitals, an incredible boon to be able to automate that process and make it faster and less expensive.
So does the visual representation itself, does that just enhance the experience? Where do you see this technology going?
Yeah, so one of the things, so my company builds something called Human-AI, and that's the core AI that allows it to speak, interact, hear things, and just work with people more like us. So it's more user-friendly than an Alexa or other voice interface. And we also gave it a person, a hologram or a picture on a screen, so that it can look at you and it can interact with you and it can see your body language, see your facial expressions, and get a better idea of what's your emotional state, what sort of context are you asking this question in, and when are you speaking, when are you looking at it. So by putting up a visual representation of a human, we're actually giving the target human that we're looking at the ability to interact with something.
Well,
and
keep going, sorry.
Oh, and to bring them in, to say here's something to interact with, if it's a puck sitting on the cupboard of a Best Buy, nobody knows to walk up to it, and that's customer service. But if you've got a Best Buy employee on a hologram, it's like, oh, and it says, hey, come here, can I help you?
What I think is so interesting is a lot of these technologies like AI, just even like basic internet access, isn't accessible for a lot of people in poverty-stricken areas around the entire world.
Yeah.
But you just said you went to Honduras. How scalable is something like that?
So like that. So if you can have an Android phone with a 3G connection, and one person in a remote town has that's such a powerful tool for them to communicate and do things with the outside world. A lot of people still don't read or write, so a lot of the text interface is lost to them. But if you can make it a voice interface and you can put a character on it so it can see them and look at them and sort of synchronize to what they're saying and tell when they're talking more easily, it's a hugely powerful tool.
Fascinating. And so I'm also curious about what is AI? Is it machine learning? Have we reached AI yet?
So
what's your take on that?
There's so many different definitions, but so artificial intelligence, I think a lot of us agreed, describes machines that can think and do stuff. And there's sort of been 3 generations of it. There's machine learning, which is just equations fitted to data. They're trained by linear regression, and they can do simple things like segmenting. Deep learning is layers of nodes. They call them neurons, they're not really neurons, that are then fitted to data by training the connections or fitting the connections to the data input and output. And although we call that AI and we call that learning today, that's really statistically fitting a mathematical system to a whole bunch of data to make it reproduce inputs and outputs. So the 3rd generation is to do more neuron-like spiking neural networks that actually can recreate the way the brain works, the way signals move in time and space, and it integrates and does much more complex operations. So that's what we're working on right now.
And we were speaking earlier, Brent, you were kind of talking about we've modeled it after how the brain works. What do you mean by that?
Yeah, so our brains are much more complex than what deep neural nets are today. So the neurons in our brains emit all these signals in time and space that travel through the brain to other neurons. There's synapses in between that change those signals or pass them through in different ways. And a lot of that creates computational circuits, logic, or things that are able to have memory, that are able to do cognition on things that deep neural nets will never be able to. So in order to make something that can actually think, that can actually work the way our brain does, we need a more complex model underneath to be able to do that. And to do sensory cortices, we also need a bidirectional system that can both take an image, take it in, reduce it to an idea that's more abstract, or expand that idea back out to what we expect to see. And those 2 systems work against each other or together to develop our senses and to develop how we learn to see and hear and interact with the world. And that's very different than deep learning, which learns by labels and inputs.
What excites you most about AI, and kind of where are we in the contingency or the continuum of AI?
So I think AI, we're at that place where up till now we've had deep learning and very powerful tools for doing specific tasks. And we're about to move into the area where we can do much more general learning, things that actually interact with their environment, see, hear, and learn as they operate, and then to be able to evolve those and make them from the intelligence of a mosquito today up to much more intelligent, much more interactive over the next few years. So that's where you get exponential technology, when you can grow, evolve, and refine something that learns. Then you can make intelligence.
It's interesting. I'm really curious to see how it's going to impact the world in years to come. But from when you start, you said you were in computer science. You said, was it some big word about?
Aerospace engineering.
Ooh.
Engineering physics,
there
math. I learned a lot of math.
My background is now exploited in that area. But how has it changed since when you started, and how much faster of a pace are we moving at right now?
As far as artificial intelligence?
Yeah.
So I think we saw the first real boom in 2012, 2013, when people started to train deep neural networks, especially convolutional neural networks, on GPUs, and they were able to do large image databases like ImageNet very quickly and get much better accuracy than people had before. And so that's caused sort of the explosion in the 2nd generation of AI we have today, where all these special purpose applications of deep learning are starting to do really tough challenges, like doing medical imaging, like doing speech recognition, but they also hit a wall because they can't learn beyond a certain amount of within the bounds of their training data, within the bounds of their complexity of their network. They hit bottlenecks of just things they can't get past.
Right. Okay, well that makes sense. Well, it's exciting times. I'm very much looking forward to it. So Brent, the last question I'll ask you is leadership. What are some of the things that we need to be thinking about before we just keep go with AI in terms of its impact on society or the environment?
Yeah, I think we always need to be conscious of when we're building something new, what is it displacing? So if we're suddenly putting people out of jobs, or we're suddenly causing disruption in a field by changing the way it works, we have to do a bit of study with that. We have to introduce it and test it and find out how will it impact and what can we do to mitigate that. So with our systems, we're trying to say this is, if you had a bank and there was an ATM and there was a teller, this is somewhere in between. It's not a teller, it's not going to replace your job, but think of all those mundane, horrible things you just do every day, over and over.
Yeah.
It can take over some of those, and you can focus on the more interesting things. So I think that's a good way to think of AI as an assistant that can help you and boost people rather than a replacement.
Well, let's hope they can conduct interviews in the future too. All right, everybody, thanks for tuning in for this interview with Brent Oster of ORBAI. Brent, thank you so much for your time.
Yeah,
again.
thanks. Much appreciated.
Learned a ton, and we're excited about the future of AI because it's in good hands.
Thank you.